afternoon, good day, depending on the time you are seeing this video. Today, I want to teach you how to derive the trigonometric ratios for special angles. 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So now let's go to let me teach you how to do that using the equilateral triangle and the square. Now, given an equilateral triangle, triangle A, B, C, in which each side equals 2 units. So let's have an equilateral triangle. This is an equilateral triangle, not drawn to scale. So now we know the properties of equilateral triangle. Equilateral triangle is the triangle whose 3 sides are equal, and automatically the interior angles are meant to be 60, because you know that sum of angle in a triangle is 180 degrees. So if an equilateral triangle has all the sides equal, then the angles should also be equal, and then that means the angles are going to be 60 degrees each. 60 degrees each angle. Then each side is 2 units. Each of the sides are 2 units. Now, if I bisect this triangle, if I draw a diagonal from this point A, B, C. If I draw a diagonal from A, it will touch line BC, thereby bisecting line BC. So if I bisect line BC, so now let's draw the diagonal. Draw a diagonal. If we draw a diagonal, we have something like this. We are going to have something like this, which bisects these 2 sides, making it 1 unit. So this is 2 units. Remember, this is ABC. So making this angle here 30 degrees, and this one here 30 degrees. Then here is 60, and here is 60. So these are the special angles. 60, 60, and 30, they are special angles. So now remember that this is the perpendicular bisector of line BC. So since this is the perpendicular bisector of line BC, we have the perpendicular angle here, which is angle 90 degrees, right angle. Then we can now bring out one of these triangles. Let's bring out one of these triangles. So let's bring out one part of the triangle. So this is 60 degrees, this is our 90, this is 30 degrees, and this is 2 units. This is unknown, and this is 1 unit. So from this triangle, right angle triangle, so this is called right angle triangle. Right angled triangle. So now from this right angle triangle, we're going to make all our derivation. So let's start from here. We're going to find using soccer tool. We're using what? Soccer tool to do that. So soccer tool says sine theta is equal to opposite over hypotenuse. Then cos theta as cosine theta is equal to adjacent over hypotenuse. Then we have tangent theta is equal to opposite over adjacent. So using this, we're going to get the cosines of the angles. So let's draw our table here. We're going to fill the table later. We're going to have our angles, sine, cosine, then tangent. So we'll start with the first one, 30 degrees, angle 30 degrees, 60 degrees, still coming to 40 degrees, and then 90 degrees. These are the special angles. I'm going to define them today. These are in degrees, So these are special angles that are going to be found in degrees. So I'm going to find these special angles. So let's start with 30. Sorry, this is 45 and not 40 degrees. This is 45 degrees. So let's find sine 30 degrees. Let's find our sine 30 degrees using this formula. Sine theta equals to root to the hypotenuse. So we're using this sine theta equals to opposite over hypotenuse. So first of all, you have to identify your opposite from this triangle. Which one is opposite to 30 degrees? 1 is opposite. So to find sine 30 will be equals to 1 over hypotenuse, which is 2. And that is the value of sine theta from this triangle. So sine theta is equal to 1 over 2 or 0.5 in decimal. So let's find cosine theta. Cosine theta is equal to adjacent to the hypotenuse. From this triangle, adjacent, of course, this line is the adjacent. This line is the adjacent. So we need to find our adjacent. Let's call it x, unknown. So our adjacent is unknown. So we have to find our adjacent using Pythagoras theorem. To find our adjacent, adjacent using Pythagorean rule. So I'm going to do that. Say that, and Pythagorean rule says that c squared equals to a squared plus b squared. Making it 2 squared is equal to x squared plus 1 squared. So 4 is equal to x squared plus 1. So making correcting like terms, we have 4 minus 1 equals to x squared. And 4 minus 1 is equal to 3, is equal to x squared. Therefore, x squared is equal to root 3. So here is root 3. So x is what? Root 3. So why isn't root 3 here? Root 3. Why isn't root 3 as our adjacent? So now to find our cos theta. Cos theta now will give us adjacent over hypotenuse. So cos theta equals to adjacent to the hypotenuse. Our adjacent is sub 3. Hypotenuse is 2. So this is the value of sine cos 30 will give us sub 3 over 2. So for this decimal part of it, to give us, when you divide, it's going to give us sub 3 divided by 2 equal to sub 3 sub 3 So 3 divided by 2 gives us 0.8660. So that is the decimal value of that. Decimal value. Then let's go for tangent theta. You know that tan theta is opposite to our adjacent. Coming to this triangle, we have our opposite. Look at the opposite of 30. 1. Then adjacent is what? Sub 3. So tan theta will equals to 1 over sub 3. That's what we have here. 1 over sub 3. Or changing that to this thing, I will have divided by sub 2. Give us 0.05774. 0.5774. That is for 30 degrees. So these are the special sines and cosines and tangents of 30 degrees. Half root 3 over 2, 1 over 3, then let's go to 60 degrees. Still on the same triangle. Look at 60 degrees. Sine 60. So now we have finished everything about 30. Let's go to 60 degrees. Looking at 60 degrees, using sine theta. Sine theta will be equal to opposite to the hypotenuse. So this is our opposite. You can see from the triangle. This is opposite to 30. Sorry, opposite to 60. This is opposite, facing 60 directly. That's the opposite of 60. So hypotenuse is 62. So sine 60 will be equal to opposite sub 3 over 2 hypotenuse. So sine 60 is equal to sub 3 over 2 opposite to the hypotenuse. If we change this to decimal, still give us the same thing here, 0.8660. Let's find cosine 60. Cosine 60 degrees. Cosine equals to adjacent over hypotenuse. This is still adjacent and this is hypotenuse. So cosine 60 is what? Cosine 60 is equal to what? Adjacent over hypotenuse. Adjacent. What is adjacent to 60? This is it here. Then hypotenuse is 2. So adjacent to the hypotenuse gives us 1 over 2. 1 over 2, which is equal to 0.5. Then we go to tangent 60. Tangent 60 will give us tan 60 is equal to opposite over adjacent. Tan 60 equals to opposite over adjacent. Tan 60 equals to opposite over adjacent. This is opposite of 60, so 3 over 1. So give us sub 3 over 1, which is equal to sub 3. So that will give us sub 3. Then in decimal, sub 3 will give us, sub 3 gives us give us 1.7320. So that is 60. Now, to find 45 and 60, we need to draw another figure, square. We need to draw a square. We need to draw a square of size. A square of size 1 unit each. So now, I'm done with this. Let me wipe this and draw a square to do that. So to get that, given a square of size 1 unit, given a square of size 1 unit, we have given a square of size 1 unit, so we have want to look for the This is a square. Each side is 1 unit. Of course, this asterisk I'm making here, this arc I'm giving here, shows you that each side of this square are equal. So in the square of side, 1 unit each. 1 unit each. So to draw, I'm going to draw a diagonal to this square. If I draw a diagonal, so I'm going to have, so let me say I have A, B, C, and D, okay? C and D. So if I carve out one portion of this square, remember each angle of the square is 90 degrees. Each angle, interior angle of the square is equal to 90 degrees. So these are, so I'm going to take out this, but I'll have something of this nature. I'm going to have something like this. I'm going to have something like this. 90, 45, then 45. Then I'll have diagonal x unknown, and this is the 1, this is the 1. Now to find the unknown x using Pythagoras rule, c squared is equal to a squared plus b squared. So our c squared is x, the longest side of the triangle. So x squared is equal to 1 squared plus 1 squared. So our x squared will be equal to 1 plus 1. 1 squared is 1 plus 1, which is equal to x squared is equal to 2. So our x is equal to root 2. That's sub 2. So this place is equal to sub 2. So that's what we are going to use as our hypotenuse, sub 2. So now, using this triangle, let's find sine, cosine 45, tangent 45, and the sine 45. So sine 45 is equal to opposite over hypotenuse, which is opposite of 45 here is 1, opposite here is 1, hypotenuse is sub 2. So 1 over sub 2. That is the sine 45, which is 1 over sub 2. Then in decimal, it's going to give us 1 divided by sub 2. Give us 0.7071. That is for sine 45. Let's find cosine 45. Cosine 45 is equal to, cos theta is equal to adjacent over hypotenuse. This is adjacent, this is adjacent, this is hypotenuse. So cos theta is equal to adjacent over hypotenuse, which is sub 2. So 1 over sub 2. Cosine 45 will give us 1 over sub 2, which is also the same. Sorry, opposite over adjacent. I mean opposite over adjacent, not opposite over hypotenuse. Opposite, opposite, opposite. These two are opposite. 45 is there, 45 is there. These are opposite. Opposite over adjacent and also adjacent. This is also adjacent. Because 45 is on top of the line. So sine 45 is 1 over 1, which is equal to 1. That is there, sine 45. Then let's check tangent 45. Tangent 45. Tangent 45. Tan 45. Tan 45. Tan 45 is equal to, tan theta is equal to opposite over adjacent. This is opposite, this is opposite. So this is opposite, this is opposite. This is also adjacent, adjacent. Tan 45 is there, opposite over adjacent. Why cos 45? Cos 45 is close to the adjacent of hypotenuse. Sorry. Then sine 45 is opposite over hypotenuse. So tan 45 is still adjacent over hypotenuse. 1 over sub 2. That is tan adjacent over hypotenuse, which is equal to the same thing as 0.7071. Then let's find tan 45 opposite to adjacent. 1 over 1, which is equal to 1. That's tan 45. So that is it, class. That is it. So that's the, and then let's go to 90 degrees. We have to find sine 90 degrees. Sine 90 degrees. Sine 90 degrees opposite of 90. Sine theta, sine 90 is equals to opposite of hypotenuse. Let's go to the other triangle. We have a equilateral triangle. This is our 90, this is 60, this is 30, this is the sod, this is 2, sorry, this is 2, this is sod 3, and this is the 1. So to find sine 90, sine theta is equals to opposite over hypotenuse. Opposite over hypotenuse. So we have, which is opposite is opposite of 90 is 2 over 2, which is equal to 1. So from here, opposite of 90 is 2. Hypotenuse is also 2. So sine 90 is equal to 2 over 2, which is equal to 1. So let's find our cosine 90. Cos 90. Cos 90 is equals to adjacent over hypotenuse. So what is our adjacent? This is adjacent of 90. This is adjacent of 90. So we're still using this again. This is adjacent of 90, adjacent of 90. So cos 90 will give us 0. Cos 90 gives us 0. This is adjacent. This is adjacent. And cos theta is equal to adjacent over hypotenuse. So when we divide adjacent by hypotenuse, it will give us adjacent over hypotenuse will give us 0. So let's check. We have 1 divided by 2, 2 was 0.5, and then sod 2 divided by 1, then sod 2. So sine 90 is equal to 0. 0. Why cosine 90? Cosine 90 equals 0. Then cosine 90 is 0. Then tan 90. Undefined. Tan 90 will give us what? Undefined. Undefined. So write undefined. 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 These are special angles, and they are tan, sine, and cosine ratios. These are special angles. So we are going to be using this angle in our calculation. We are going to be using this in our calculation. So let's find out, let's solve an example on this. Let's solve an example. Let's take an example where we employ the knowledge of these special angles in our calculation. So there's a question here from Wayek question, which says, that is the Wayek question here, says in the diagram below, let's take an example, solve the example. Example 1. In the diagram below, Q, R, S is a rectangle. It's a rectangle. Then K, line PK is equal to 15 cm. Line SK is equal to line KR. And the P angle PKS is equal to 37 degrees. Full stop. Calculate correct to 3 significant figures. I, line P, S. I, line S, K. And I. The area of the shaded portion. The area of the shaded portion. So let me draw the shape, rectangle, according to the question given to us. So this is the rectangle. Now in the rectangle, we are told that according to the diagram given to us, these two sides are equal. And this is triangle P, rectangle PQ, RS. So this is K. So here is 37 degrees. Then this is the shaded portion of the rectangle. This is the shaded portion. This is the shaded portion. So that's the question. We are going to solve this question right now. So this is wire question. In the triangle, the diagram below, PQRS is a rectangle. PQRS is a rectangle. You can see this is the rectangle. Now, PK, line PK, this line, PK is equals 15 centimeters. So, line SK is equals to line KR. So this line is equal to this line. You can see the sign given to you. Then, and PK, angle PKS, angle giving PKS. So K is in the middle. So the angle is at K. So that's the angle. Plus 37 degrees. Now calculate correct the three significant figures. Line PS. So let's start with somewhere. Line PS is the height of the rectangle. Let's find the height of the rectangle. So we already know that here is what? 15 centimeters. So solution. So line PS, remember it is given. PK, line PK was to 15 cm. Given. It is given. We did not just manufacture that, it is given. And this is it. So now we are finding line SP and the line KS. So to find line SP, so to find P, line PS, we are going to use sine formula. I took this line PS. We have sine theta is equals to opposite to the hypotenuse. Sine theta is equals to opposite over hypotenuse. So sine 30 degrees is equal to, let's PS be here, line PS over hypotenuse is what? 15 cm. So we're going to cross and multiply. When we cross and multiply, we have line PS is equal to 15 times sine 30 degrees. So from the question, what is sine 30 degrees? Sine 30 degrees is what? Sine 30 degrees from the question. PS is equals to 15 times 0.5, or use half. 15 times 0.5. So we have 0.5. So we multiply 15 by 0.5 or by half, give us 7.5. That's what is going to give us 7.5. 15 divided by 0.5 give us, okay, 15 times not divided, 15 times 0.5 give us 7.5. So this is line PS is equal to 7.5 cm. That is this line. So that's the line PS, 7.5 cm. Now let's find line SK. To find line SK, we can now use Pythagoras, or we can still use adjacent over. We can use cos theta. Cos theta is equal to adjacent over hypotenuse. Cos theta is equal to what? Adjacent over hypotenuse. So to find line SK, we have cos theta is equal to adjacent over hypotenuse, which is equal to adjacent over hypotenuse. Let's call this unknown x over 15. So cos 30 is equal to x over 15. Find our cos 30. So x cross and multiply, we have x is equal to 15 times cos 30, which will give us, what is cos 30 from the table? Cos 30 will give us 0 points. So cos 30 is 15 times 0.8660, which will give us 15 times 0.860 give us 0.860 times 15 will give us 12.99. So now we have 12.99. So approximately, to rest significant, we are still going to have 13 centimeter. The nearest number 13 centimeter. That's the line. That is the line. SP. Therefore, line SK is equal to 13 centimeter. So now, the next question says, calculate the area of the shaded portion. Now we know that here is 13, here is 13, but the two lines are equal. Since they are both 13 cm, we are going to draw our shape to give us, so this is 13. To find the area of this rectangle. Now the area of shaded portion, now let me explain before we solve. To find the area of the shaded portion, we just need to find this triangle, or we find the area of the whole rectangle, the whole area of the whole rectangle, then subtract the area of the triangle from it, or we simply find the area of the trapezium. So I'm going to use both formulas. I'm going to use both formulas to solve this. Now I'm going to wipe this paper thick. I believe you are taking it down. I believe you are taking the table down. So now, method 1, to find the area of the shaded portion. Method 1. We start is equal to area of shaded portion. Area of shaded portion equals area of rectangle minus area of triangle. Area of the triangle. The triangle in the figure, not on general basis, but on this diagram. Area of this rectangle minus area of this triangle. So that's good to go. So it's equal to, which is going to give us, area of rectangle will give us length times breadth minus 1/2 times height times base, or times base times height. So we have our area of rectangle to be the height from here, ES is given. ES is 7.5. To have 7.5 times the length, which is 13 plus 13, is equal to 13 plus 13 is equal to 26. 26 minus 1 over 2 times rectangle. In rectangle, in triangle we have height and base. So in the triangle, we have height of the triangle to be 7.5 times the base of the triangle is there. Base of the triangle is 13 cm. So now, let's solve. We have 7.5 times 6. 7.5 times 26 times 26 will give us 195 minus 0.5 times 7.5 times 13 will give us 48.75, which is equal to, which will give us 195 minus 48.75, which will give us 146.25 centimeters. Now, remember, the question says we should correct the three significant figures. We have 1, 2, 3, 4, 5 significant figures in equals to, which is equals to 146 centimeters squared is the area of the shaded portion. To 3 significant figures. So now, I'm going to use the second method. To find this. So the second method is just to find the area of trapezium. That's the second method. To find the area of trapezium. So that's what I will do now. Method 2. Method 2. To find the area of trapezium. Find the area of the trapezium. Find the area of the trapezium. We know that the area of trapezium is equal to 1 over 2 into a plus b times height. So area of trapezium is equal to 1 over 2 into, our a is this side and this side, a and b. So we have here and here, which is 13 cm, and this is 26 cm. So we have 13 plus 26 times 7.5. This will give us the area of trapezium. If we solve the bracket, we have 1 over 2 into 13 plus 26 will give us 39. 39 times 7.5. So finally we have 39 times 7.5. 39 times 7.5 will give us 39 times 7.5 will give us 292.5 divided by 2 give us divided by 2 give us 146.25. So also approximately the three significant figure 146 centimeters squared. That's the area of the shaded portion. You can see that we got the same thing, irrespective of the fact that we use different methods. We still got the same answer. That tells you that it is correct. So you can find the area of the shaded portion using this, area of the rectangle minus area of the triangle, or find the area of the trapezium directly to get the area of the shaded portion. Thank you. Bye.